Primes and composites. First, let's look at composites or composite numbers. When we spoke about even numbers, we said that even numbers were the same thing as doubles or 2 times another number. And we said that when you multiply two numbers together to get a third number, these numbers, the result is known as a multiple. And just as the result is known as a multiple, the two numbers that are multiplying together to give that number are known as factors. Multiples are the result, factors are the numbers being multiplied together. Let's look at another even number. We had 12, for example, and 12 is the same thing as 2 times 6, and so 2 and 6 are known as factors of 12. It's important to know that all even numbers have factors. Well, all numbers have factors. You're always going to have the number multiplied by 1 as one set of factors. So all numbers are going to have at least two factors. But many numbers also have others as well. So 9, for example, is also equal to 3 times 3. These are also factors. And so any number that can be made up by multiplying numbers other than 1 and the number itself is called a composite number. Or a simpler way of saying this, composite number has more than two factors. So let's look at some more examples of composite numbers. 24 composite? Well, straight off we know it's even, so it must be 2 times something, and in fact it's 2 times 12, and so yes, indeed, it is composite. Other factors though, 1 times 24, so we know that there are at least 4 factors, and in fact you could also have 3 times 8 and 4 times 6. So altogether, in fact, we have 8 factors. So indeed, it is composite because 8 factors greater than 2. What about 17? It's not even, it's odd. We know that it has one pair of factors for sure, 1 times 17. Does it have any others? No, so not composite. So we want to look at those numbers that are not composite, and we give them a special name, and that name is prime numbers. And prime numbers can be defined as all the numbers that are not composite, or more correctly, numbers that have two factors only. So let's look at some examples. What about 5? How many factors does 5 have? We know that it has 1 times 5, that's one pair. Does it have any others? No? 2 factors only, so it is prime. What about 21? We know it has 1 and 5. Sorry, 1 and 21. We know it's not even, so maybe it's prime. Are there any other factors though? Well, yeah, because 3 times 7 is also equal to 21. 4 factors, so it's actually composite. Not prime. What about, and I'm going to throw you 2 tricky ones. What about the number 2? You know that it's an even number, but does that mean necessarily that it is a composite number? It has as factors 1 times 2. Does it have any others? Well, no, it can't have any others. It has 2 factors only, and that is the definition of prime, so it is prime. So 2 is the only prime even number. And the final tricky one, what about 1? Well, 1 really only has one factor, 1 times itself. So it can't be prime, but it also isn't composite. And so 1 is neither prime nor composite. Next, prime numbers, you're going to try some exercises for prime and composites. Let's look at a couple more examples. So let's try and determine whether these numbers are prime or composite. The definitions that we have there: prime, only 2 factors, 1 in the number, or composite, more than 2 factors. So let's first look at the first one, which is 17. What are the factors of 17? 17 only has 1 times 17, so that is prime. 18. 18 has 1 times 18, but it also has 2 times 9, and it also has 3 times 6. So it has altogether 6 factors, so it is composite. 4. Well, 4 has 1 times 4, but it also has 2 times 2. And of course, because 18 and 4 are even, we could have straight away said that they were composite, because we know that all even numbers except for 2 are in fact composite. 23, 1 times 23. Any other factors? No, so that is also prime. What about 33? 1 times 33. And well, it also has, what about 3 times 11? So that one is in fact composite. Another way we can think about this is talking about divisors. So composite numbers have divisors, that is, numbers that can divide exactly into them, but primes can only be divided by 1 and themselves. Let's look at some examples. We remember that 18 was a composite. 18 can be evenly divided by, for example, 3. 3 into 18 goes 6, whereas for a prime number, like 17, it can only be divided by either 17 and itself. 17 and 1. A prime number can only be divided by 1 and itself. Let's try and list off then all of the prime numbers. We said the first prime number is 2. 3 also can only be divided by 1 in itself. What about 4? 4 is an even number, so that's definitely not prime. 5, that can only be divided by 1 in itself. 6, no. 7, 8, no. 9, well, 9 is 3 times 3. 10, no, 10 is even. 11, 12 is even. 13, 14 is even. 15 is 5 times 3. 16, 4 times 4. 17 is the next one. 18, 19. 20, not 21, we saw that earlier. 22, 23, and maybe you can come up with additional prime numbers. So that's primes. Primes only divided by 1 and themselves, and composites more than 2 factors or divisors.